Welcome to this tutorial session. So basically I'll be solving problems based on what we've previously learned. The theory, we've learned some theory and some understanding. So I'm going to give some or solve some problems that you typically find in some textbooks or that will help you understand the problems better. So first of all, the first question we'll be solving is given Sij. This is a matrix, so it's like a tensor, basically 3 by 3. And we have AI, a vector. Evaluate Sii. Sij, Sij, Sjk, Skj, right? Then this, and this. So basically, if you've done linear algebra before, some of these things, I mean, the notations might look a bit different, but it wouldn't be anything out of the ordinary. So the first problem, Sii. If you can remember, Sii we've learned before. When we talked about this double index, we referred to the trace of a tensor or a matrix, right? Yeah. So the sum of the diagonal elements. Now, if you remember Sii, what that means is S11 plus S22 plus S33. Sii is equal to 1 is 1. That is, if you look at it, this is 1, 1, 3. That's the values we are looking at. Plus 1 plus 3 to give you 5. Now for B, it says Sij, right? It says Sij, Sij. Meaning, once you get the value of one Sij, you multiply by the same value itself, multiply by itself. So we're going to be looking at what this means. We're going to be looking at every element in the matrix. Right? Because if you go by using I equals to 1, 2, 3, and j equals to 1, 2, 3, the way we've done previously, then you go through all the elements in the matrix. Let me explicitly write that. So what that means is if you have Sij equals to, let's start with 1, 1, right? Because if it's like it's Ij, this Sij, it should give you S1, 1 plus S2, 1 plus S3, 1. Then you do that for I. Well, this is when I is equal to 1, right? You're going to do the same thing for I equals to 2 and I equals to 3. If you do that correctly, it will give you S11 squared, so S12 squared, S13 squared, right? Plus S21 squared plus S22 squared plus S223 plus S31 squared plus S squared 32 plus S33 squared. Right. So Sij will be equal to S11 squared is that's it's just like saying row 1 column 1. Right, that is this 1 squared 1 2 1 3 S2 2 1 S2 2 S2 3 like that there. So you're simply squaring all the entries in that. So if you look at that, that should be 1 plus 1 squared is 1 plus 0, 2 squared is 4, 0 plus 1 plus 4 plus 9 plus 0 plus 9 equal to, so this is 1 plus 4 is 5, 5 plus 1 is 6, 6 plus 4, 10, 10 plus 9, 19, 9 plus 9 is 28. So that's what Sij is. Now, if you look at C, it says Sjk, Skj, right? Okay. Now, yes, from what we can see in the question, we have Sij, right? But in reality, the truth is, whether it's Sij or Sjk, it's technically the same. It's technically the same because you are the one who makes the choice of this. But why we're given a different notation here, first of all, is to differentiate it from this one here, 1, 2. It's also show to you, if you look at this, Sjk and Skj, what that means is one matrix, we have a matrix and that part is inverted, it's turned, right? Yeah. So all you need to do is to split that out you start with j equals to 1, 2, and 3. So s j1k sk1, right, plus s2k sk2 plus s3k sk3, right? Then the next thing we do is to have k equal to 1, then 2, then 3, starting with 1 first. So for s11 s11 plus s21 s12 plus s31 s13, you're done with the first one, right? For k equals to 1. For k equals to 2, it will be s12 s21 plus s22 s22 plus s32 s32, right? Then for k equals to 3, it will be s, that's from here, right? s33 s, let me see. Okay, yeah, let me see. Yeah, for k equals to 3, sorry, no, I made a mistake there. Sorry, I mean, I actually pointed at this, that's wrong. We're expanding from this point, right, again. Yeah, so it will be S1, S13, S13, S31 plus S, write this clearly, plus S23, S32 plus S33, S33. I hope you easily follow what we're doing. So basically what we've done was, for these values, right? You start with j equals to 1. So you put, for j equals to 1, you have this expression, this one. So for k equals to 1, you write all of this 1. For k, you get the first 3. For k equals to 2, write all of this, you get the second 3. For k equals to 3, write all this out to get this, this, and this. Now, if you look at this matrix already, this is S1, that's, look at this matrix already. This is S11, okay, let me do this. So let's sum all this, all of this we've written, all of this, let's sum them up, right? S11 is 1, so equal to, let's do this, S11 is 1, S11 times 7 is 1, 21 is 0, 0, that's row 2, column 1. So without 2, 3, that is, you're following it like this, right? This. So S31 1 3, so S1 2, that's 1 2, you get 0 0 plus, yeah, right, I'll just write them in the, I'll just fill them up, but you can cross check and verify according to what is in the graph, I mean according to what's in the notes. 3 2 plus 0 2 plus 3 3 equals to 23. Now in case, just not to get confused, 1 1 1 1 is this 1 1 1, right? If you take another one, let's say 3 3, column 2, that's 3 3 is this 3 3 3 9. If you look at this 2 3 2 3, that is 2, which is 2 3, which is 2, then 3 2 3 2 0, like that, 0 3 2, yeah. So if you follow all this and you check them out, you get this to give you 23. Right. So question, so D. So let's make some room. So D, the D part of the question says we should find AM, right? Now, if you look at this, it's just trying to tell us this notation is just a matter of notation. The question says A subscript I, but I mean, it's still the same thing basically. Sometimes you have a different notation, but it doesn't change what the problem is itself, right? Yeah. So AM now. So you're trying to pick out the entries. So if, okay, let's look at this way. M equal to 1, 2, and 3, right? So let's assume 1 is 1, 1, A2, and 2 plus A3 and 3, which is the same thing as A1 squared plus A2 squared plus A3 squared. So whether it is M or it is I mean, the question the other writes I. It's just a notation, just to make sure you understand the right placement and what to do with it. So basically that will give you 1 squared plus 2 squared plus 3 squared. This is 1 plus 4 plus 9, which is 10 plus 4, 14. Right. Then the E part of the question is, let's look at that. Okay. SM N X equals AM A this. Now we're going to expand this the way we usually expand stuff, right? We expand this the way we usually expand stuff. So M from 1, 2, and 3. Then when we're done with M, we pick N, 1, 2, and 3. So looking at this, it should be, let's say M is 1, right? So it will be S1N, A1, AN plus S2N, A2, AN plus S3N, A3, AN, right? Then if you pick just this one first, it should give us S11, A1 plus S12, that's N now is now 2, right? Oh, yeah, 1, 2, S13, A1, A3. Plus for this now, the next one, right, will be S21, A2, A1 plus S22, A2, A2. If you feel I'm too fast, you can pause the video and look at what I'm doing slowly or so. Yeah. Then for this one, S3, S31, A3, A1 plus S32, A3, A2 plus S33, A3, A3. I hope this makes sense, right? Yeah. So though we are using the expression SM here, I mean, it's still the same as the matrix written there as SIJ, right? Right. So we're going to look at, let's look at, if you look at this very closely, it's still the same matrix as this one, and it's this one too. Yeah, this is the A part, right? This is the A part. So if you look at it closely, we're going to write out the expressions. We have, if you look at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So these terms will be equal to S11. If you look at this, S11 is 1. If you look at S11 is this, right? A11 is 1. A11 is 1. So you multiply all three together. S12, 1, 2 is 0. So automatically everything here becomes 0. S13, 1, 3 is 2, right? Then A1 is 1, A3 is 3. So that's the same, that's just the way to do that. So I'm going to write it very quickly. Then you can also pause the video and verify if what I've written is correct. So this will be 1 plus 0 plus 6, 0 plus 4 plus 12 plus 9 plus 0 plus 27. Alright, so this should give us 1 plus 6 is, this is 10, 11, 11 plus 11, this 2 is 21, and 27, 9, 4, 59. Okay. So equal to 59. Just make sure you understand how we got this. But if you look at, like, for instance, let's take S33, right? S33 is 3, A3 is 3, A3 is 3, right? 3 times 3 times 3 will give you 27, which is this, right? So don't forget, let me just change the color to give A1, A2, and A3. And here, if you look at this one close, yes, S11, S21, S31, S12, S2, S12, S13, S22, S33, S23, right? S32. So that's just it. Now this is clear. Then the sixth question says, you see, this was sixth question. This one, if you look at this sixth question says SM. This question doesn't look too different from this, right? This is SMN, but this just shows this. Yeah, it's that simple. SNM equals to this for this part. AMAN give you 59. Well, you can verify too, because if you can go through the whole steps, but if you verify, you get the same answer, in the sense that you pick M from 1, 2, and 3, then N from 1, 2, and 3. If you do that, you will get the same answer. Yeah, that makes sense. Okay, so we're going to do question 2. Let me just take this a bit downwards so we can have more space to work with. So given that Tij equals to 2 mu Eij plus lambda E sub k conical delta ij, show that Tij equals to 4 mu squared Eij plus Ekk squared, excuse me, bracket open, 4 mu lambda plus 3 lambda squared. Now, don't get confused. Basically, if you can remember, capital letters, that's a tensor, right? That's for a tensor. Small letters is for it's for a vector. We don't have a vector in this problem. Also, we have lambda, those are scalars. So the question has given us this Tij, that's equals to 2 mu Eij plus lambda Ekk, this. So we're going to show how this is equal to Tij. Now, first of all, Tij is like, if in the previous problem, when you have this, we could square them up, right? So what that means is we're going to be squaring this one. So 2 mu Eij plus lambda Ekk Dij, 2 mu Eij plus lambda Ekk Ij, right? I hope this is clear. Yeah, so what we need to do now is to expand them accordingly and see what we get. Now, let me give some context and numbering to this so that it does make sense. 1, 2, 3, and 4. So we're going to be multiplying 1 and 4, right? So if you multiply this and sorry, let's start with 1 and 3. Sorry, 1 and 3. 2 times 2, it's 4 mu squared EIG EIG. 1 and 4 now will be 2 mu lambda EII EKK. Yeah. Now you may ask, look at this EI. How did we get this EII? Remember this expression? I'll write this in colored. So 2 mu times 2 mu k ek, right? Then if you look at this lambda EIG, this gives us EII. We've studied this expression before, right? So when you see that, you can substitute, and that's what I've done automatically. 2 mu EIG, times this. So 2 mu lambda EIG times and conical delta gives EII, this. Plus 2, now we're going to be multiplying 2 and 3, right? So it will be 2 mu lambda EKK EII. So, just for looking at that, 2 and this is 2 mu k EKK will remain. Now, DIG, that's conical delta IG, and EIG is still the same expression, which I've substituted automatically. Then we're going to multiply 2 and 4. 2 and 4 will give us lambda squared EKK squared delta II. That should also be straightforward, because you look at lambda squared EKK squared. If you multiply this conical delta IG, conical delta IG gets this. I hope this makes sense, right? So for most, then yeah, okay, this should be equal to more simplification, mu squared EIG EIG plus 2 mu lambda. Now look at this expression. Look at these two. Look at these two expressions. Can you see this? Can you see this? Well, they're technically the same, so you can square them. But it will appear as different because you need to differentiate what they were initially. So that should be let's say EKK squared plus, let me try and be consistent with the ink I used, right? EKK squared, right? The same one for this lambda EKK squared plus. Now if you look at this one, this expression, if you remember, DII, what is DII? DII is D1 1 plus D2 2 plus D3 3. For any matrix, when you sum those values up, DII, if you get 3 based on the conical delta, remember, if I is not equal to G, you get 0. If it's equal to G, you get 1, right? So that should give you 3. So you have 3 lambda squared EKK k squared. Does that make sense? So we're getting to the final expression. 4 mu is eij plus 2 mu lambda ekk squared. You see it appears 2 times, so if you add them, it should be 4 mu lambda ekk squared plus 3 lambda squared ekk squared equal to, yeah, so you just look at it, you see we can already see where the second expression comes from, so 4 mu squared eij plus, if you look at the expression, if you take out the ekk squared, you are left with 4 mu lambda plus 3 lambda squared. 4 mu lambda plus 3 lambda squared, and that's exactly what we have on top. So basically, if you look at it, this is just normal like expanding in an algebra question, but the difference was knowing what to substitute. The 3 different things we noticed were this, that's 1 delta I equal to 3. So these were the 3 things we needed to substitute. Conical delta, when you square them, it gives you conical delta I. EIJ times conical delta will only give you EII, right? So when we made these right substitutions, this is where we landed at. I hope that's pretty straightforward. You can just watch the video slowly to get a hand of what we're doing. So we're going to be solving question 3 this time. So I'm just trying to remove this up a little. All right. So for question 3, given AI, that's a vector, and B, another vector, evaluate this. So AI and BI, evaluate DI, another, yeah. So if dk equals to permutation AIBJ, so we're supposed to find DI, right? And we're told that this is the relation between them. So how do we proceed with this? Okay, looking at it, we have K here, right? So K normally should be 1, 2, and 3, right? Yeah, so let's start with K equal to 1. K equal to 1. IG1 AIBJ. Now, if you remember what we learned with permutation, that will make the simplification of this very easy. If the order is correct, it becomes an even permutation on a +1. If you have let's say ij or some odd number permutation, it gets -1. If you have it like repeated iij something of that nature, we get 0. Let's write 0 here and no permutation. So if you look at this closely, this expression, let me bring this. Remember, I've already this is the original one expression here, right? So if you put k equals to 1 first, this. Now, looking at this very closely, permutation ij1 aibj, with what we've written here, right, it will tell us what this is. So any permutation that has to double up, like double II, will give you a 0. But if the order is wrong, it gives you negative. If it's correct, it gives you +1. So if you look at this, D1 equal to E. So 2 2 3 1 A2 B3 plus 3 2 1 A3 B2. Now, if we say, let's assume we're starting with I equals to 1, right? If I is equal to 1 already, just looking at I, 1, J1, A1, BJ, this automatically becomes 0. Why? Because this is 0. So any of the values of 1 for this will not work. But if you pick 2 to start already, if you pick 2 already, okay, if you pick this 2JI, there's hope that's going to work, right? Provided J here is 3. If it's 1, is 0. If it's 2, is 0, right? Yeah. So that's the logic behind coming straight to this point. I hope that's clear. Let me explain with another example. I know it could be confusing sometimes. So we have EIJ. Let me use a different colors to just give one. So we have EIJ, IJ1, AIBJ. This is actually the original expression already, but we've already substituted for 1. We'll do that for 2 and for 3. But knowing fully well that if you substitute for 1 for K here, if you substitute for 1 for, K already equals to 1, right? Yeah. So the next thing is K equals to 1. K is the last one, and it's the last value, and it's just 1, like free index. So if we substitute for 1, for I equal to 1, for instance, it invalidates this. Because if you put I equal to 1 here, this becomes 0, right? If you put I equals to 2 here, if you put I equals to 2 for I, then J must be 3, which is this one, right? So you can see if I is equal to 3, then J must be 2, which is this. Any other combination will give a 0. You can write all of it out and see what that gives you, but straight away, because of your understanding of permutations, you can understand what is happening. So D1 will be equal to this 231 permutation is even, so it will be A2B3. 321 permutation is odd, right? Because after 3 is supposed to have 1, so it will be negative A3B2. I hope I'm really making sense with this. So it's not difficult, right? Then if you look at this from the question, if you look at this point here, A1, A2, A3, B1, B2, B3. Right, okay. Let me take that off so that if you're going through the questions, you can easily pick out and understand what I have done. I'll try and upload this PDF. So A2 from the question, 2, B3, 3, A3, 0, B2, 2. So that should be D1 equals to 2, 3 minus 0, 2 to give you 6. Similarly for, now this was I equal to, for K equal to 1 here. So for K equal to 2 this time, it will become, because look at this is DK, EIJK. So so if we remove this K and put 2 there, it will be 2 equals to 1J2 AIBJ, right? So the same logic applies. If any value of I that is 2, we turn all of this to 0. So the highest I can be should be 3, right? After 2, the next one should be 3. And if I is 3, the next one here, J should be 1, because any other thing, if it's 1 or 2, to turn this to, if it's 2 or 3, it will turn this to be 0. A, 3, B, let's see, A3, okay, B, J is 1, okay, this 1, so this is 1, right? So plus, if you look at where is the expression, yeah, this one. So if it's this, so if this I, first we've tried 3, that's fine. If I now is 1, right, j2, so here should be 3. If this j is 1, it turns this to 0. If it's 2, this becomes 0 too. But it's only 1, 3, 2 that will give you a value, right? Then a1, because 1, a1, b, j is the middle one, 3, so this is 3. So if you look up, if you check the values of a3, so 3, 1, 2 is positive permutation, so it's a3, b1. 1, 3, 2 is minus because that's not the right order, it's odd permutation, a1, b2. So this should be 0, 0, minus 1, 3 equals to minus 3. Similarly for D3, 1j, 3ai, bj, right? Because if you look at for k, the value of k here, where is it? K, that's what you, k here. So you replace this k with 3, right? So it's eij 3. So if I is 1, let's assume I is 1, if I is 1 here, then j naturally should be 2, right? 1, 2, 3. Because if it's not, if it's 1, 0, if it's 3, 0. So b, sorry, a1, b2 plus 2, 1, 3, a2, b1, right? So equal to a1, b2 should be 1, 2 minus, let me not jump that step, a1, b2, 2, 1, 3 is negative permutation, a2, b1, right? To give us 1, 2, 2, 0, 2. How this makes sense? Okay. So the second part of the question says show that the result is the same as this. Let's make some room. Sorry, I had to write out the questions ahead of time because to avoid taking a lot of time in doing that. All right. So this is the question here. It says show that the result is the same as dk equals to a cross b dot ek. So dk is 1 cross b dot e1, right? Here for k, we're going to be trying 1, 2, and 3. Now, what this means is that d1 a cross b dot e1, if you look at d1 already, we got 6, meaning we should be able to get 6 from a cross b. Now, d2, because a cross b dot d2 e2, d3 should be a cross b dot e3. So let's just find a. If you find a cross b, we're able to get the other expressions. All right. Okay. So let's see how this works. Cross product. Okay. Where is now? Let's look at this. A. Remember, A is equal to AIEI. meaning the components of I times the base vector. I hope you can still remember that from the lecture. So what that means is A itself will be equal to it will be equals to A1 plus 2E2, right? Then B will be BI. So B will be equal to 2E2 plus 3E3. Does that make sense? Right. Let me go again. AI, it means the components of A, right? And if you look at this, we see this is A1, A2, A3, right? B1 will be B1, B2, B3. Those are the components of them, right? Now, so for us to get the AI, will be A equals to AI, EI, B, BI, EI. So we'll be able to simply multiply this by the base vectors to get this, right? Okay, so A cross B now we give you cross product. This is how you do it. A1. I'm sure you can still remember this sort of. So for the expression we got there, A is equal to, if I can remember this correctly, A1 plus 2E2. B should be 2E2 plus 3E2, right? So you're going to write it out like this. E1, E1 we have E1 we have a component 1, E2 we have 2, E3 0. For B we have 0, 2, 3. So to find the cross product of this, it's like it's similar to like if you're finding the determinant, right? So look at E1. So look at this. Does this make sense? So 2 times 3 6 E1 because minus 0. Then remember this is plus negative E2. If you take E2, then you're simply looking at 1 times 3 minus 0 to give you 3E2 plus E3 and to give you 2 times 1 2 times 1 2. Let me see, E3, right? Covering this part will give you 2 minus 0 2, right? So it's 2E3. So basically this is A cross B. Now for our expression of A, so for D1 it will be A cross B, which is 6E1 minus 3E2 plus 2E3 dot E1. For D2 it will be 6E1 minus 3E2 plus 2E3 dot E2. D3 will become 6E1 minus 3E2 plus 2E3 dot E3. Now if you can remember well, this A cross B, don't forget this is how we did that. All we needed to do is A, remember, we already have what A is, right? And we have the individual parts that E1. So we have to write it in this form, and B equals to BI dot E1. When we wrote it in this form, cross product, we get this, right? So it's like the way you do your determinants, E1 2 times 3, E2, like you pick this one and you close this line and this line, and you're left with this and this. So that way we're able to get this, right? So now if you evaluate this, dot product of E1 times this will give you 6. Look at this, because if you can look at this, E1 6E1 will give you 6. All these 2 becomes 0. E2 times E2, this becomes 0. This will give you minus 3. This is 0. E3 0 0 2. So that will give you minus 3 and 2. Now if you look at these values, it's exactly what you have here. 2 minus 3 and 6. That's 6 minus 3 and 2, which is 6 minus 3 and 2 here as well. I hope this makes sense. So question 4. So for question 4, question 4 looks pretty simple. It says if permutation ijk then tensor ij equals to 0, show that tij equals to tji and and delta chronicle delta ij permutation ijk is equal to 0. So eijk and delta and tensor ijk is equal to 0. Right. Now, don't forget, once you see chronicle delta, just once you can remember the property of ijk, let me use a little, let me go a bit numerical. 1, 2, 3, right? You get even permutation for +1, -1 for odd permutation, 1, 3, 2, and 0, 1, 1, 2 to give you no permutation for 0. So if you just know the ones that fall into this category, one trick is if you know values that fall into 0, if you know permutations that give you 0, automatically they are ruled out in the expression, so you don't need to evaluate that. So if you have eijk this, right, let's start with, you always start with the ones that have just one variable. Look at ijk, ij2, but k is just 1. So if k is equal to 1, tij, right, is equal to 0. So if you want to expand this, if k is equal to 1, if I can, let's say I is 2 first, then the only logical position for j to be is 3. Any other thing else will give you 0. Then j 2, 3, right, plus if I is equal to 3, j, the logical thing to give j will be 2, then 1, 3, 2 equal to 0. Like if you expand this out to all the full expressions you will get, a lot of them will give you 0 and you'll be left with this, only these 2. You can try that out. So now to epsilon or permutation 2, 3, 1 will give a positive value, right, to give it 2, 3, and 3, 2, 1 will give negative, which will be 3, 2, to leave you equal to 0. So t2, 3 equals to t3, 2, which is same thing as saying tij equals to 3ji. So this holds. That's just for k equals to 1, right? For k equals to 1. Similarly, you can do the same thing for k equals to 2 and for k equals to 3. For time's sake, I will simply write that out very quickly and you can verify on your own much later. And for k equals to 3, it's the same thing basically. Tij equal to 0, right? So if j is already 3, the logical thing for I to be, let's say I is 1 for j. If I is 1, then j should be 2, 3, 3, 1, 2 plus. If I can also be 2, then 1, 3, t 2, 1 equal to 0, right? 1, 2, 3. 1, 2, 3 is T1, 2. That's the even permutation. 2, 1, 3 is negative, so we already have the negative here. T2, 1 equal to 0. So T1, 2 equals to T2, 1. So for all these problems, we'll be able to show that this is this and show that this here is this. So I think there's a part B to the question that says and delta, conical delta, and this is equal to 0. Equal to 0, right? Okay. For this, as I said, since k is just 1, you start with k equal to 1, right? Conical delta 1, 1, e 1, 1, k plus delta 2, 2. Okay, yeah, I will explain why I'm doing this. Okay, delta 3, 3. Now, you see, we went from I 1, 1. Any other, if you notice, conical delta, any other thing, 1, 2, 3, 2, 2, 3, will give you 0. So if you expand this completely, you need to try that on your own. You discover that most of this resolve to 0. So I'm writing out only the ones that will not give 0. So delta 1, 1 will give 1, right? This will give 0 because we haven't repeated 1, 1, and this will give 0 permutation. Delta 2, 2 will give 1. This will give 0 permutation. And delta 3, 3 will give 1. 0 permutation. 0. I hope this makes a lot of sense. You can always pause the video and take a closer look at what I've done. So the last question, question 5. Question 5 is pretty straightforward, but it's just to give you an idea of how to write in indical notation. When you see indical notation, it's still the Einstein notation we've written, or index notation we've been talking about, right? So we write the following indical notation where A, B, C, D are vectors, and B, Q, R, S, F are tensors. Sometimes I've seen these people write tensors like this or like this. I mean, I see a couple of this. So we have B, so number 1, or A, B dot A equals to Q transpose R dot S dot B. Now I want to write this in indical notation, right? For tensors, we usually have double index, right? IG. Now A, remember, if you're supposed to be able to multiply both of them, right? When you multiply both of them, you're supposed to get what? A vector. So this should be A. The notation to use should be what? J. Now why should it be J? Because when you solve this, you get I. And let's say C is the vector, so it will be CI. So you see why it's reasonable to get this. There must be some compatibility, right? So that's not the part of the question for now, but let's look at that. Right. Then Q is supposed to be IG, right? Right, that's Q is supposed to be IG, right? But it's being transposed, so it's supposed to be QGI, right? And remember, what you get on the left hand side should be equal to what you get on the right hand. So if you multiply this, you're supposed to get an index with I, right? So this, so QIJ, because we're transposing, it becomes QGI. R, now R should be able to be compatible to be able to multiply this, should be JL, right? Because if Q, let's say QIJ, this should be RGL. These J's should be able to cancel. Notice these inner places should always match, right? Then S should be what? LK, right? Because we have an L here, so the L cancel this. Then B, the last one, B is a vector, should be K, right? So let's just somehow verify if what we've written is proper. So if we have QIJ, this will leave I out here. then you have L here, right? These L's will cancel. Okay, let me not confuse you, let me make it explicit. So if you see you have a G here, these G's remove each other, leaving you with an L here. This L leaves, right? So these two K's cancel each other, leaving you with only an I. And on the left hand side, you already have an I alone. So that's correct. So B, F equals to gamma C dyadic D. This dyadic product of dyadic, right? Y is gamma, gamma which is a scalar in this case. F is a vector, F is a tensor or a matrix, so it's Ij, right? So what you get from the left hand side should also be equal to Ij when you multiply. This is scalar, it remains C I D G. Remember, dyadic product is different from matrix vector multiplication. Dyadic Cij will give you dyadic product. If you multiply that, it's supposed to give you a tensor, right? Which is Ij, which is C equal to what's on the left. But if it's a normal vector of vector multiplication, you get a scalar, right? So the final one, C. No, C is a bit tricky, right? So let's say Q is Ij. So if Q is Ij, Q transpose written here should become QGI. S, normally if you have the G, right? So S, let's assume S should cancel the immediate one, J with the new one, K. So JK, right? So you can see this unique sign. This is what we call contraction, right? So F, give IL, right? You're contracting that. Equals to G. G is a scalar. G, trace of B. Trace of the matrix, if you remember, it's BII. So it's BII. Now let's see if we are correct by now. There are naive approximation by IJ, JK. So this goes off IK, right? Then IL. Yeah, let me see. K, IK. Yeah, okay, this IK goes off then, yeah. So that's how you solve for, this, the little challenge is the fact that we have a contraction here. But when you have a contraction, this Q, oh, I see where I made a mistake. Okay, so let me repeat this so you can understand what I've just done. So let's say QIG, right? So QGI, because it's transpose on C, SGK. This G's, the G's are supposed to take care of each other, right? So we have IK, then then Q this time, because let me see. Yeah, there's a Q, right? Q is already IG itself normally, but we cannot use yeah. But if you notice, if you write IG, you're going to be confusing you're going to change the dynamics of everything. You must be consistent. So KL is the same Q, but you understand? KL. So this K is off, right? We have one L. Then there's a contraction FIL equal to a trace. It's G. Then so you see these two Q's or JK left, so you'll be left with IK, right? Then KL, this K off, you'll be left with IL, right? Then this IL, because of a contraction, becomes L. You remove this L to leave with II. So this is basically your solution. I hope this makes sense to you. So thank you for paying attention to this tutorial. It's been a bit long, but it will help you trying to understand some of the problems we've been solving and give you an idea of what you need to do. So in the next tutorial session, this is a very common expression to know. Yeah, you can memorize it, can be your cheat sheet also. You can also attempt to solve it, right? You attempt to solve it and see what you get to get the values. The hint I'm providing is as you have to consider 6 cases. I will be equal to j, I equals to k. I mean, just make these substitutions for this. They are the 4 free indexes, and see what you get. So thank you for listening to this tutorial session. If you need more questions, you can put them in tutorial in the comment section, and I'll solve more questions. Thank you.